Hello everyone, welcome back to Mr. Myers Math Channel. Today in Chapter 10, Day 8, we're going to talk about an introduction to probability, and we're going to focus on theoretical and experimental probability. I can't stress enough, this is just going to be basic probability problems. So if you already know your basic probability, feel free to skip this. All right, let's get into the first example. First, we're going to talk about what probability is. The probability of an event is a number from 0 to 1 that tells you how likely it is to occur, okay, where increasing likelihood corresponds to a higher number. So the probability being 0 means that event cannot occur. The probability being 1 means the event must occur, guaranteed that thing is going to happen. If the probability is 1/2, that means that that event is equally likely to occur or not occur. So a probability can be expressed as a fraction, decimal, or percent. So most of the time, I'm going to write it 3 different ways. So as a fraction, as a decimal, and as a percent. Okay, so let's get into the very first topic, which talks about theoretical probability of an event. When all outcomes are equally likely, the theoretical probability that an event A will occur is the number of outcomes in event A divided by the total number of outcomes. This just means the number of different ways that event A can happen divided by the number of different events that are possible given that scenario. So the theoretical probability of an event is often just called the probability. So we can see this diagram here outlining what we mean by the probability of event A. So we have this bigger ellipse which encompasses all the different possible outcomes of this scenario, and then this smaller ellipse which talks about those that pertain to event A. So for this, to find the probability of event A occurring, we have 3 in event A and then 10 in the overall possible outcomes, so that would just be 3 out of 10. All right, so let's take a look at this example with the spinner. So what is the probability that the spinner shown lands on red if it is equally likely to land on any single section? All right, that assumption has to be made that it's equally likely to land on any section for us to be able to calculate that probability. So to calculate this probability, we're just taking a look at how many different spaces can the spinner land on, and then how many are actually red. So in this case, we have 3 red spaces, and then a total of 8 different spaces. All right, and this is a simplified fraction, so we have our probability being 3/8, 0.375, or 37.5%. All right, if we want to figure out the probability that the spinner lands on green, there's no green spaces out of a total of 8 spaces, so that would be 0 out of 8, or 0 over 8, or just 0. So there's a 0% chance that that event can happen, which means that's impossible. It's not going to happen. Then finally, we want to find the probability that the spinner does not land on red. So we just take a look at the amount of spaces that are not red, which would be 1, 2, 3, 4, 5, out of the total of 8 spaces, and that would give us 0.625 or 62.5%. So that is more likely to happen than not. All right, let's move on. Now let's say a jar contains 5 red marbles, 3 blue marbles, and 2 green marbles. We want to find the probability of drawing a blue marble. So first, in total in this jar, there's 10 marbles to choose from. Okay, and when we reach in and grab one of those marbles, we have 3 different blue marbles that we could pick. So the chances of this happening would be 3/10, 0.3, or 30%. Okay, in order to find the probability of drawing a red or a green marble, we need to know how many red marbles there are and green marbles there are. All right, there's 5 that are red, 2 that are green, so we would add those together. We have 7 possible successful outcomes for this event to happen. All right, 7 out of 10 would give us 0.7 or 70%. Okay, now let's talk about our standard deck of cards. We pick a card from a standard deck of 52 playing cards. We want to find the probability of picking an 8. we have to know how many 8s there are in a deck of cards, and that would be 8 of spades, 8 of diamonds, 8 of hearts, 8 of clubs. So that would be 4 out of the 52 cards. And of course, we're going to want a simplified fraction here. Make us happy. 1/13, and that would also be 0.077 or 7.7% chance. All right, if we choose one deck of card randomly from this deck of 52 playing cards, the probability of picking a red king is going to be the amount of red kings out of the total deck of cards. All right, so there's 52 cards in the deck, and then how many red kings are there? There's a king of hearts and then king of diamonds. So that would be 2 out of 52, which is 1/26th in simplified form, or 0.038 or 3.8%. Awesome. Now we're going to involve some fundamental counting principle, and we're also going to involve some permutation combinations and factorials. So let's move on. So let's say we have 8 songs on our iPod, and we set our player to play all the songs on the list in random order without repeating any songs. Okay, we want to find the probability that the songs play in the exact opposite order they're listed in your playlist. All right, so if our playlist has, songs 1, 2, 3, 4, 5, 6, 7, 8, playing them in the exact opposite order would be 8, 7, 6, 5, 4, 3, 2, 1. If we think about the number of different ways that this exact event can happen, well, we only have one option for what can go first, one option for what can go second, third, fourth, and so on. There's only one way that these songs are going to play in the exact opposite order. All right, and then we got to figure out how many different events are possible in this scenario. We have 8 songs, okay, and where order does matter, and we can't repeat any of the songs. So we have 8 options for the first song, 7 for the second, 6 for the third. Once that song plays, 5 for the fourth, and so on. So to simplify this, that's just 1/8 factorial. And if we remember from previous lessons, 8 factorial is 40,320. So this is 1 out of 40,320, which is going to be a very low percent chance of occurring. That's 0.000025 or 0.0025%. In part B, it says 3 of the songs on the playlist are by the same group. Okay, what is the probability that 2 of the songs by this group play first in any order? So let's say, these songs are by the same group here. We have to figure out how many different ways can this event happen, and in this case, we're only concerned about the first 2 songs that are played. So the number of different ways we can play those first 2 songs is 8 different songs could play first, and then 7 different songs could play second. Okay, now we have 3 songs to choose from by that same group. So 3 different songs could play first, and once that song plays, we have 2 options for the next song. So that's 6 cases in which this happens out of 56 total possible scenarios here, and that would be 3/28, 0.107, or 10.7%. Awesome, we just got a couple more to go here. Now we're going to switch roles, and we're going to talk about experimental probability. So for a given number of trials of an experiment, the experimental probability that an event A will occur is the number of trials where A occurs out of the total number of trials. So this is what we would see in like a real-life survey or something. All right, so we're going to look at the next example, and this is a survey. It's a survey containing the different types of favorite footwear amongst students in a school. So we want to see what is the experimental probability that a randomly chosen student from this survey prefers sneakers. First, there were 1,700 students that were surveyed, and notice we see that 820 of them prefer sneakers. Okay, so that would be 820 out of that 1,700. Okay, if we simplify that fraction, that's 41 out of 85, which would be 0.482 or 48.2%. Then in part B, we want to see what the probability that a randomly chosen student prefers shoes or boots is. Now, the amount of people that prefer shoes is 204. The amount of people that choose boots is 120. So if we add those together, that's 324 people that prefer either shoes or boots out of that 1,700. Now we're going to simplify that fraction, which is 81 out of 425. And that would be 0.191 or 19.1%. All right, last example here, we're going to talk just really briefly about geometric probability. So we want to find the probability that a dart thrown at the target will hit inside the target. Obviously, there's a lot of assumptions that are being made in this type of example. The diameter of the circle is 4 units and the side length of the square is 7 units. The dart is equally likely to hit any point inside the target. So we have no trends in how we throw these darts. All right, it's just going to be totally random. We're good enough to hit the board, but we have no idea where we're going to hit it. All right, so if we were finding the probability that a dart thrown hits the shaded region, that would be the area of the shaded region divided by the area of the overall or total figure. Okay, in this case, the shaded region is a circle. So it's just really the area of a circle divided by the area of this square. Now, if we did not remember, area of a circle is pi r squared, and then area of a square is just side length squared. All right, and we have enough information to complete this. So that's pi times 2 squared. Since the diameter is 4, that means the radius would be 2. The side length of the square is 7. So that's pi r squared over 7 squared. So 4 pi on 49. If we round this to the nearest thousandth, that would be 0.256 or 25.6%. Awesome, folks. If you like this or found this helpful, please like, subscribe, and share. Thank you, and have a great day.